Here we see an example of a function that's actually made up of what could be looked at as two smaller functions or two individual functions. And graphing a function like this isn't as straightforward as graphing a normal single trig function equation. And one of the most efficient ways to graph equations of this type, to sketch a graph fairly quickly, is to begin by first of all looking at it as two individual equations by looking at the individual parts. So we can look at this as these two individual functions and if we begin by graphing them individually on one set of axes, we'll be able then to do what's referred to as graph by addition of ordinates. Remember, the ordinate is the y-coordinate of an ordered pair, whether we call it the y-coordinate or z or whatever letter. The ordinate always refers to the second coordinate. And so addition of ordinates means we're going to look at these two functions individually in a position where we can fairly accurately approximate the curve we'll get by adding the two, or in this case subtracting the y-coordinates from each curve. So it looks like this. Let's start by looking at 2 cosine of x. Our cosine function here has a amplitude change because of this 2 that's multiplied times the cosine function, which means the y-coordinate from the normal cosine function for every point on that function is going to be doubled. In short, that means we've got an amplitude now of 2 above and 2 below the x-axis. So our cosine curve normally starts at its highest point, so its first point here would be 2. Then we know that it's going to hit its lowest point, its minimum, at pi, and it's going to be back to its highest point at the end of one revolution around the circle. It's on the axis at pi over 2 and at 3 pi over 2. So that's our normal looking, it's going to be our normal cosine function. And here it is with the curve drawn in. Now, y equals sine x is just the normal sine function. And now you see the curve with the sine sketched in as well. Now, how do we go about adding these coordinates? We're going to look at combining our y-coordinates as this equation specifies. We're going to subtract our y-coordinates from these two curves. Well, that means that wherever one of the graphs intersects or intercepts the x-axis, has a y of 0, it's real easy to figure out what the result of the subtraction is. In this case, our 2 cosine x has a y-coordinate of 2 and the sine x has a y-coordinate of 0, so obviously the 2 stays. Coming on over here, the y-coordinate for each of the 2 graphs is the same. So regardless of whether they're both positive or both negative, in this case both positive, we know that subtracting them right here is going to give us 0. Right here we have a y-coordinate for the sine of 0, so we'll be taking I didn't mean to do that. We'll be taking, in this case, the negative 2x, or the negative 2 from the cosine, and subtracting 0. So again, we're down here at negative 2. Right here, the y values on each graph are the same. So again, we have another 0. Right here now, we've again got that peak. And then right here, notice that we have the 0 for our 2 cosine x minus a positive 1. So 0 minus 1 is going to be negative 1. So again, remind yourself that you've got to be very careful to maintain your subtraction in the correct order. Okay, well, we have already what looks like a fairly well mapped out sketch, and it would be really easy to just quit with that and say, yeah, that's nice, smooth, looks good. However, let's do a little bit more checking here. See, if we stop here, we're assuming that our f of x function has an amplitude of 2 as well. But looking in, well, let's look right over here just before the y-axis. Notice that right here we have a positive value for our cosine and a negative value being subtracted from that cosine, which means that this amount of distance is actually going to become positive and therefore be added on to the original graph. So if I was doing this with paper and pencil, I would take my pencil and I would use it to figure out that length right there, or to come up with an approximation. And then I would move my pencil, carefully preserving that length, up to where it goes on the top graph, yielding for us the result of subtracting those two functions. So we can see that this particular graph has an amplitude that's actually higher than either of the other graphs, and any place where we end up adding or subtracting two coordinates of the same sign, this is going to happen. Now, in this section right here, we've got 2 cosine x being positive and higher than the positive sine x. So in this case, this distance is going to be taken off of our 2 cosine x. So let's do a point in there. So again, I would, let's say that's good enough right in there. And I need to pick it up. Missed it. And now it's going to subtract from the curve. So there would be a point. And notice that whenever the graphs intersect, their relative position with respect to each other switches. Here the cosine's above the sine, they intersect. Now the sine's above the cosine. They intersect here again, coming from sine above cosine. Now cosine's back above sine. So that means that in this section right here, when I do 2 cosine x and get this negative number and subtract this positive number, I in essence end up adding 2 negative values. So that means that if I take, let's say, this point right here, since it's nicely on those dots, and I pick it up and physically do the addition. Now we can see that we're getting a pretty good idea of what this curve looks like. We can see that it goes below -2. It goes above +2. Let's do one over here in this section. And this is really what you do is you continue on and put in, and you measure enough to give you a pretty good accurate representation of what's actually happening. And with trig functions in particular, you have to be careful to make sure that you get amplitudes right and that kind of thing. Now, in this case, step back here a minute, we're taking a negative value from 2 cosine and subtracting a negative value from sine. So they really are going to subtract, because the minus the negative value for sine x is going to be positive. So this amount then is going to subtract off of our original 2 cosine. Technology is great when you use it correctly. You know what I'm saying? Okay. Again, in this case, right here on the axis, we have the 2 cosine value as being 0, and we're going to subtract a -1. So that's going to put us up here at 1. And then we already have a pretty good clue over here that as we get back to where both of these 2 curves begin their cycle, meaning that our final graph is going to have the same cycle, we already know that if we subtract 2 points in here, a positive minus a negative is going to get us up above, just like what we see about right there. So at this point, we've sketched out a pretty good path of what that new function is going to look like. We've accounted for the fact that the amplitude is higher or larger than either of the original, because in some places you're actually combining 2 coordinates with like signs. And here we see our final combined graph in blue.